Hey, how's it going? I wanted to show you something that I've been working on over the Thanksgiving weekend. I was writing a Terraform file that I wanted to show you. The file actually creates a search cluster by default using Ansible and Terraform. So this searcher cluster will be spun up on AWS. And then what I wanted to show you was I wanted to set up a Haproxy. So if you don't know what Haproxy is, it's been around from 2000. It's been well maintained and it is quite stable. A lot of large organizations have been using Haproxy, and this is a kind of a load balancer solution that you can try out in your network without doing any change to your existing searcher cluster on your Splunk side. So you don't require any kind of changes for setting up a Haproxy. So if you are an organization with a searcher cluster, or if you are trying out Splunk and then you want to try out a load balancer, then you can look at Haproxy. Other options are Nginx. That is also a very good solution. If you are a F5 customer, then obviously you can use F5 as well. So for the purpose of this video, let me show you the Terraform file that I created. So I'm going to start up the file, then I'll explain how this thing works. Terraform apply. So this Terraform file that I written, it installs a Ubuntu 20.04. That is done. So this is something I have written so that only I can access the security group into which the Terraform into which the instances are being loaded. And then I created the security group rules, all the ingress ports, egress ports, things like that. By the way, I'm not a Terraform DevOps expert, so this whole Terraform could be improved in different ways, but anyway, so what I done is created the security group, right? So all the rules are already set up. So I'm spinning up 7 instances, so that should be 5 searched peers, 1 searched deployer, and the Haproxy, right? So this have been set up. So the volume size is all very small because this is a lab, but you can use this Terraform, or you can follow this method to create your own Terraform instance, right? So anyway, so what I done is so from here what I'm doing is I'm creating the host file, right? So this is for the Ansible part, right? So I created the host file, so all these things will get created by Terraform itself on Ansible format, so that so once Terraform finishes writing, we can start running Ansible, right? So I'm going to run Terraform now, so you can see Terraform starting to create all the instances that I require. Alright, coming back to the script, what I done is created the host file for Ansible, alright, and then this is the actual Ansible playbook. Alright, downloading your Splunk copy, extracting Splunk copy seed file. So all these things are done so that I don't have to manually do anything, right? So I'm changing the way Splunk starts to daemon, so that it can so services can be started as a daemon, right? So I'm changing it to system control here, right? So once that is done, we can start configuring the searcher deployer, right? So this is one file that gets written onto the searcher deployer, right? So let me show you this one. So the Terraform has completed running, right? So I'll show you the final file that got created by Terraform. So this is the file that got created by Terraform. All the details that you need to complete the setup has been automatically generated, right? So this is my private IP of the newly created instance on AWS, right? So private IP is there, and this is the private IP of the newly created search and deployer, right? So that is there. So all the cluster commands have been listed out, 3, 4 and 5, because we have 5 peers, right? So once that is done, I'm restarting all the peers, right? All the Splunk server peers are going to be restarted, and then I'm going to initialize the cluster captain, right? Cluster captain command have been populated by default. All the private IP addresses have been listed, right? And then once all that is done, so while we're talking about this, let's run the Ansible playbook. Host and then my Ansible. So this one will start running your Haproxy installation. The whole lab installation, that is including 5 peers, 1 search deployer, and the Haproxy. Right. So coming back here, so that has been done, and then the Haproxy config file. So I'm going to use a block-in file, so that using that I'm going to fill this detail. So this detail have been pulled by Terraform. So this is the actual detail. This is the detail of the host name of the Haproxy, right? The private IPs of the 5 servers that are sitting in the backend, right? So what it is trying to do is any request that goes to this IP address 172.31.15.60 on port 80, which is the normal HTTP port, will be redirected to port 8000. So that is what Haproxy is basically trying to do, right? So while Splunk is being installed by Ansible, let me go here and show you the instances that got created, right? 7 instances have been created here. All right, so let's go to the security group. So this is the security group that got created by Terraform, the one that I just started up, right? Here all the rules that I require are there, and then it's only allowed from my IP address, because this is a lab setup, so I don't want to allow IPs from outside, right? All these things have been configured by default using the Terraform file that I created. So anyway, so that is done. These are the instances that got created. So the ones that are running, so it's all named correctly. So all those things got created, right? So anyway, so this is the script that I written, right? So let us wait for Ansible playbook to finish running, and then we'll pick it up from there. Right, now we can check all the tasks for the Ansible have been completed. So downloaded, Splunk got extracted, seed file got copied, systemd enabled, Splunk got started, SSD got configured. All the commands that I shown you earlier, it got finished, and the Haproxy have been configured. All right, now let us check this Haproxy, right? So first of all, what we have to do is, I want to see what the IP address of the Haproxy is, 137.185.113. So now I'm going to this IP, right? So this is the IP address, no port number. So this is the IP address of the Haproxy, and I'm getting the Splunk server, right? So I'm getting Splunk server. Search and clustering is working, right? So you can see all the cluster members are up. You can run your search, you can do your thing. It works exactly like a normal Splunk search. So what I'm trying to say is, there's no change that I have done on your normal Splunk site, right? Everything that you see has been done on the Haproxy only. So if you want to test out this this solution, you can always do it. If you don't like it, you can always remove it as well, right? So let me show you how the proxy is working. All right, so this is the Haproxy's tail file. So I'm tailing the var log Haproxy log, right? So this server or server 1 is serving all my request, right? So let me show you this, and now I'm going to refresh this, and then you can see server 1 is giving me all the response, right? So let us go back to the Ansible file, and I'll show you what server 1 is. Server 1 is search at 1. Server 1 is search at 1. So the method that I've been using is round robin, all right? But then what I'm doing is I'm using sticky session, right? So that means every time my IP address accesses this accesses the Splunk Haproxy, it will show me one search it, right? It will show me one search it. So this is how sticky is working, right? And now what happens is, let us do like this. I'm going to I'm going to log into sh1, right? So this is sh1, the same sh1 that you see here. So and here I'm going to stop Splunk, right? System control stop Splunk, right? I'm going to stop Splunk, and then even if it stops, I will still see request for working on my search it, right? So let me just wait for that Splunk to stop, right? But that wouldn't matter to me because my Haproxy will still show me files and the web page from a different search it, right? So now Splunk is stopped on sh1, right? Now if we go back to the HA log file, server 2 is serving me now, right? The end user actually didn't notice the search at 1 going down. The end user is just continuing his search here, right? Now let us log into search at 2 and turn that off and see what happens, right? sh2, I'm logging into sh2 now, right? So I'm in sh2, system control stop Splunk, right? So Splunk is going down on sh2 right now. I'm being served by sh2 right now. It detected a issue with L4 issue with sh2, right? But then all my requests started going to sh3 now, right? So end user, in a matter of few milliseconds, the switch has been completed already, and I'm in sh3, right? But then if you check here, I'm still accessing the same IP address. So this is basically load balancing, right? So if you go to search and clustering, right, it will show me as 3 search peers have been turned off, right? Down and shutting down. So 2 is down, 3 is up. Now I cannot turn down one more because then I will lose majority. So if I lose majority, then search it will not start working. But even if that is the case, even if I keep turning down all these ones, still I will get the search it, because Haproxy will keep shifting my IP to the next one. Whoever is responding will get my request, right? So if you come back here, so I'm using a round robin method, but then again I'm using a sticky session, right? Because Splunk, if you don't use a sticky, Splunk will start throwing up errors, because round robin without sticky, Splunk doesn't like it. It will throw permission errors and you will not see your UI work properly, right? So I'm using sticky session. So anyway, everything that you see here, you just have to follow my method and you can set up Haproxy by yourself. So let me show you the main file here, cat etc Haproxy and then Haproxy config, right? Managed by Ansible, right? So this has been managed by Ansible. So good thing here is, if I want to spin up new instance, all I have to do is change the number here, add a new instance, right, and then change the Terraform playbook, and then if I run it again, the next server will show up here. So I can automate the whole thing again on another level using CI/CD, right? So every time a server goes down, then you can always spin up a new one using Terraform, Ansible, and your CI/CD solution, right? So anyway, so if you have any questions, you can reach out to me, right? Around on LinkedIn. So if you reach out to me, I can help you out with any issues, right? So that is all I have. So if you like the way the Ansible or Terraform have been set up, you can get back to me and let me know that. If you have issues with this Terraform file, you can know that as well. And if you have any projects that you would like me to work with you on, I'm always looking for a job change, right? So if you have any openings in the Middle East, then you can reach out to me and we can have a chat about that. All right, so that is all I have, and we will chat again later, guys.